So hi, I'm Etienne Bernard, and I'm working at Wolfram Research in developing functionalities for machine learning. And I'm going to talk about some functionalities that we recently added to the Wolfram language and that you can use in Mathematica 10. Okay. So machine learning is a very broad field. We can say that basically anytime you compute something from data, you're doing machine learning. So what I'm going to talk about is a bit more restricted. It's about teaching a program a task from example of this task. And this task would be, for example, image recognition. So for example, in this case, classify if it's a picture of a face of a cat or a face of a dog. It could be text classification, so classifying text by topics, for example. So here it would be determining if a text conveys a positive sentiment or a negative sentiment. And more generally, prediction from features. So we want to predict a value, whether it is categorical or numerical, from some variables. And here, for example, it's on a data set of persons, predicting their height as function of their age and their gender. Okay. And for that, we developed two functions that are called classify and predict. So classify deals with predicting categorical values, such as cat or dog, that you can say also are classes, while predict deals with predicting numerical values, such as predicting the height as function of some features. Okay, so the key point about this function is that they are automatic. So the usual process of machine learning, it requires a lot of expertise. For example, you need to know about what model you can use. You need to know what kind of preprocessing you have to do in order to use this model. You need to know how you will select the best hyperparameter of the model with some cross-validation techniques, and then how to select the best model with some cross-validation techniques or other techniques. And what we wanted to do is to automatize all this process in order for basically anybody to do machine learning, because we believe there's many applications everywhere in your work, but unfortunately not everybody knows how to use these techniques. So okay, this is just some examples of what preprocessing can be done. So of course, feature extraction. So when you take a feature like an image or text, you need to extract features from it. So for images to be numerical features, for text it might probably be tokens of the words, or I don't know, some statistics about the characters, or things like this. Input missing data. Many times in real data set you have missing values, so there are techniques to input this missing data. Sometimes for some algorithms you have to encode nominal variables as a vector of numerical variables, standardize numerical variables, do some dimensional reduction when you see that the data are actually embedded in some lower dimensional space. There's some technique to project onto that space, and then it makes the algorithm faster and sometimes better. Or simply feature selection, where you see that this feature, according to some information criterion, is irrelevant, so you don't use it for your prediction. So the model selection will be automatic as well. Here's some example of models that are into classify and predict. So some you might know, some simple model that comes from statistics, such as linear regression. It is used for predict. And it predict the value with a linear combination of the features. Logistic regression, that is for classifying, where this time it's still a linear combination of features. It's a bit the same as linear regression, but for classify. But they are wrapped in logistic functions to make it a probability. Here you can see the probability of distribution of each class given the feature. You have algorithms such as nearest neighbors, where in order to do a decision, you look in the feature space at the example of your data that are close in the feature space. Random forests, which is average of decision tree. Naive Bayes classifier. And so on. This one, Markov model that is good for text. Neural network that is good for images. And a support vector machine that you might know that is some kind of very smart nearest neighbors. And so all these algorithms are better on some data than others, and depending on the number of features, the number of examples, the type of data. So all of these, there will be heuristics to choose which model can potentially perform well on some data, and then this model will compete with each other with some cross-validation technique. It means they will be trained on some training set, tested on some test set, and the winner on the test set, or many test sets, will be taken. All right, and there's other things such as I was telling you before, such as hyperparameter selection. All these models have parameters such as the number of neighbors for nearest neighbors, number of trees from the forest, and all of them have some regularization parameters, which is parameters to prevent overfitting, to prevent having a model that goes such as this red line, and instead having a model that goes into this green line. Okay, so all this is integrated to classify and predict. So how does that work in practice? So we'll show you a few examples. So you just have to construct a data set. So here data sets, there's different formats. The simplest is just a list of examples. So for example, this first example means when the feature is 1, the value is 1. When the feature is 2, the value is 3, and so on. And you just run predict around it, and it outputs a predictor function. You can see the method that it uses. Interpreted the feature as numerical, so that's good. And then you can query this function for given features. So for example, if the feature is 2.5, what is the prediction? 4.25. So here it's some kind of interpolation of the data. Same code for classify, except that this time the values to predict are classes. So nominal values or categorical values. So it uses a function logistic regression. And again, you can ask, what do you think 2.3 is? It said 2.3 is class A. I believe that 2.3 is class A. And so here it's the same, but with a set, a feature vector with two features. So one numerical and one categorical. And same again, you can query what does a classifier function think that this feature vector is. Okay, so let me show you some example on some more realistic data set. So here I have the data set of Titanic passengers, where you have for each passenger their class, their age, their gender, and if they died or survived. And so the goal will be to predict if a passenger died or survived, given its feature. And you notice that some of them are missing, and this won't be a problem because there will be some input missing, and or the method will understand how to deal missing values. So just run classify Titanic data. Here the method is nearest neighbors that have been selected, and then you can query again. If you are in first class, 20 years old female, you survive. Third class, 50 years old male, probably die. But what's more interesting is to ask about the probabilities. So this is something that all classifier functions have, and actually all predictor function, but this time it will be distribution, continuous distribution. So it is probabilities. So it means like all algorithms are probabilistic. And this is important because probabilities convey much richer information that you can use for taking decision afterward and putting in some other whatever in your pipeline of. Okay, so you can see here that the probability, so it's quite high if you're a 20 years old female in first class, and probability of surviving is quite low in that case. Okay, so I can look also at the classifier information. So the information that I have about this classifier with classifier information. And so you have still the method, the number of class, number of features, number of examples that have been used, and some specific parameters that have been used, that have been found by classify, such as here the number of neighbors, because it's nearest neighbors, the distance function used, things like that. You can also ask, I want to know what your interpretation of features, of the type of features. And it said, I think the first one is nominal, it is a class, it's right. Second is numerical, it was an age. The third was a gender, nominal, so it's right about it. So you can use it without specifying anything, but if you want, if you're a bit more of an expert, you can also specify the method. You say, okay, I know that with this data set, it will produce good results if I use logistic regression. So you will do that with the option method. And again, you see that so the classifier changed. There's some other hyperparameters that are associated with this model. And here I just plot the probability that it founds for different value of gender and class as function of age. So you can see that being a female is always better. Yeah. Even male first class have less chance of. Okay, so here is another example, this time using images. So you have here a data set composed of, so the example of handwritten digits. Okay, it's an image. And you have to recognize what digit it was, this image is. Okay, so in order to make it a bit faster, because there's 60,000 example, I just do a random sample of 10,000 example. And I also use the option performance goal. So this is actually the higher level function you can use. You don't have to know about the models, but you can say, I want a classifier that will train fast with performance goal training speed. You could also say, I want a classifier, which should actually automatically, okay, that evaluates fast. When it's trained, when I give new data, it will give the class very fast. Or I want a classifier that quality, so I don't care about the speed or the training speed or even the memory. I just want the best. And you can ask a classifier that is small in memory. Okay, so here we're going to ask for training speed. And I'm running it, so it should take a few seconds. Take a random sample. I'm just going to take the image and I'm going to 10 random sample. And I'm going to see this random sample, what the classifier believes. So, okay, this one you got all right. I need to do it again. Uh, 62631. Okay, it got all right, but I know it gets wrong sometimes, and you might want to know how frequent, how good it is. For now, it's 100%, but we just tried with 20 examples. So you could so to do that, you take your test set and you use the function classifier measurement that take as input the classifier and the test set. You run it, and it outputs a classifier measurement object. Okay, so the classifier was the nearest neighbors. There was 10,000 examples in the test set. You also have a few additional information. And then you can query this classifier measurement object with a property you want. You can ask what is the accuracy of this classifier on this test set. And it will say it's 95.7% here. And another interesting thing, and it's actually the most useful one, is the confusion matrix. So you can ask to plot the confusion matrix. And it will tell you, for example, here, it will tell you that there is 2 that have been classified as 6. Okay? It's a matrix of giving you the number of a given class classified as another class. And actually, let's take this one, 2 as 6. And I can query this time the property examples with a 2 arrow 6. And I can have all the examples of 2s that have been classified as 6. And it can be useful to understand what's wrong in your classifier. Maybe the example were not good, or maybe you need some additional example that looks more like that, or things like this. Okay. So, okay, here's a simple example, another real example, just about text, just to show you that you can use text as well. So it will use a Markov model of actually order 0, I think. So it's just go to the unigram model for the one we know a bit about NLP, and then you can ask. What do you think this thing was about? Okay, this was about cat. What do you think this text was about? It was about dog. And things like this. And okay, here's another example of a predict this time that works on images. What we'll try to do is to predict the value of a gauge. Okay, so we have a data set of image of gauges with a value. So there's 50 of them. And I will use predict. So it will output a predictor function with the method nearest neighbors. The feature is image. Everything is right. And then I can ask, what is the value of the gauge, of this gauge? And the value is 0.75. And you can ask, as with the classifier function where you could ask probabilities, here you can ask for the distribution. So instead that it's a normal distribution centered in 0.74 with this standard deviation. So it doesn't say I'm sure it's this value. It just says this is my belief. And we can use. Okay, and this is just a small animation with dynamic where you can see. So on the left, it's a gauge that I set myself. And on the right, it will be the prediction of the predictor. So you could see, okay, so you can see some small differences There's only 50 examples, but okay, it gives you an idea. And actually, these dynamic things are really useful to understand quickly what's into your classifier and your predictor function. Like for debugging, it's quite useful. Okay, so there's another aspect of classify and predict. It's the built-in functions. So I showed you how to create a custom function with some data you have. But what we did is that internally, we trained many classifier and predictor function. And for some tasks that are common and that you would like to use. So instead of putting a training set, this time you will put just a name of the built-in function. So here it will be the name language, and it will, so it's a classifier that classifies text according to the language. So here what it says for the house is blue translated in many language. And again, I like to use this dynamic thing where I can type whatever. And it gives you the probability of the top languages. So I don't know if you have anything you want to write. Anyway, I mean the notebook is you will have the notebook, so you can play with that if you like. Okay, so another one is a Facebook topic. So we trained it on Facebook messages according to the topic, and what it says about a new computer. It's about technology, happy birthday, special occasion, this skirt looks nice, fashion, and you could ask again for example, the top probability. So I love carrots. You would say, I don't know, food and drinks, 43% of chance, 0.8, fitness, 15% of chance. Maybe, I don't know, the people who do fitness ate a lot of carrots. I have no idea. And okay, so this is a bit, a toy example, but we plan to do a more generic topic built-in classifier probably with some hierarchy of topic where you could go as deep as you want in the topics. And I think this could be useful. Okay, this is this time it's a built-in predictor function that predicts your age as function of your name. So for example, if your name is Claire, you must be 3 years old. And so of course it's not right, but what it is right about is a distribution. So I can do predicts and add the property distribution, and then I can visualize the distribution, and you see the distribution of age given that the fact that your name is Claire, which corresponds to the distribution of people, the age of people named Claire, probably in the US. To conclude about classify and predict, so it's some simple functions to do, some high-level functions to do classification and regression. And so you can have custom functions, you can use built-in functions, and what we really try to do is functions that are simple, that are automatic, so that really everybody can use. And there are some success stories of people that didn't know anything about machine learning, and even after using it, they still don't know anything about machine learning. But they managed to make their project work with that. For example, there was someone that was trying to analyze how much fire, like the size of fires in Australia, and she cut the images. The problem is that the grass always looks different. The fire after it has burned always looks different. There's some rocks. So she cut the images in many squares, and she did a user interface to quickly create a training set. And then she built a classifier, and then it worked very well. And she could, with good accuracy, determine the area of the parties that had been burned, like it corresponds to this party. There's another success story that I like. It's someone that is an engineer and he's selling devices, so it's control devices that have many options, and sometimes it just fail, and the client calls and say, why does it fail? And also what he wants is, what can I change just few parameters so it doesn't fail anymore? And then you need an expert that read in the books. It's all nightmare to answer this question, and you say, okay, do that, and still doesn't work, do that, it still doesn't work. So what he did is just use classify to construct a model to try to predict if it will work or not. Of course, it's not perfect, but it's enough to give a very educated guess. Oh, you should do that, and most of the time it will. Better than before, it could give a right answer. Okay, so I'm going to stop with that. If you want to know more, of course, there's documentation. There's a guide. machine learning. There's some example in this new Etienne things. And you should come to the workshop, speak quickly about the future, what we want to do. So quickly, so of course we want to add more models. One of them that we're excited about is Gaussian processes that are very good for tiny data set. Do semi-supervised learning is when you have data when the value is missing sometimes. Online learning, so when you want to extend your classifier function or predictor function with new data. Model combination, so the ability to train two models on the same data and then combine these two models. And actually, on my development version that I have here, it should do it. So here, if I put some text and some image, it will use two different models. It will use a Markov model for the text, another model for the image, and then combine both of them. And something that this is really exciting is about implementing convolutional neural network. So you might have heard of deep learning. So it's a model that are extremely good on images, but unfortunately they are very slow to learn. Like you really have to be an expert to learn that. And actually to automatize is very hard. We don't manage to automatize this thing. But what we can do is train ourselves some convolutional neural network. And then if you have an application of recognizing, so okay, like here, recognizing cat and dogs, you will use one of these pre-trained classifier. Actually, you won't even know about it. The convolutional neural network will start from a pre-trained convolutional neural network, and then only the first few layers will be trained in order to have a very performance classifier function, and it doesn't take much time to train and doesn't require millions of data. So it's something that can be quite powerful. And I think in the following years, we'll see many applications using convolutional network to do image, all kind of image recognition. There's also a few other functions that, many other functions we want to do. Multi-label classification, prediction, recommender system, a function that will probably be called recommend. Segmentation, tagging. So for example, segmentation could be, I don't know, you do an rating and you want to segment each character or segment words in a text, thing like that, where you could do your own segmenter or your own tagger, like you want to tag the part of speech of a word, for example. This would be an application of tagger using either Markov models or these kind of models. And a really nice function that we don't know the name yet, but that will do distribution estimation, where you give any data set, and it just learns the distribution of this possibly many variables data set. So and then you can query. You can say, what is the probability density there? What is the marginal distribution of this variable? What is the convolutional distribution of these variables as a function of these variables? And this can be a very nice function.